All right, so now we are looking at isomerism, all right? And that is like the third thing we're looking at in this series which we are going in. Remember that this is the series which is Introduction to Organic Chemistry. We are talking about things that you're going to be using. We are building it up. We're building up our house. Let's go for it. So now we are talking about structural isomerism. We want to go through this whole idea of structural isomerism. We want to see what it is about, okay? And we want to see the different types of structural isomers. And we want to be able to identify them. And okay, so first of all, let's go through the definition. Okay, we want to know what structural isomers are. So structural isomers, here it says that structural isomers are compounds with the same molecular formula, but different structural formulae. Okay, but different structural formulas or different structural formulae. So what is happening? They have the same molecular. What is the molecular formula? Well, the molecular formula is just a formula which tells you the numbers, the exact numbers of each atom that is present in one molecule of that compound. So it just tells us, okay, you have 3 carbons, you have 4 hydrogens, and you have an oxygen, something like that, okay? It just tells you how many carbons you have, how many hydrogens you have, and how many oxygens you have. So that's only what the molecular formula does. It doesn't even tell you the structure. It doesn't even tell you how the things are arranged. So when we have things that have the exact same molecular formula, but different structural formulas, remember that the structural formulas, formula now it gives you a diagrammatic representation, a graphic representation. It now shows you how the things are arranged. It could be the displayed formula, it could be the condensed structural formula. Both of them will be different. So things can have the same molecular formula, but different structural formula, the condensed structural formula or the displayed structural formula. Okay, they can be different, but having the same molecular formula, we say we have structural isomers. Don't forget that. Okay, so such compounds, the compounds that you see having the same molecular formula but different structural formulas will be called structural isomers. Give us an example. Here's an example. You have C3H6, right? C3H6. Okay, what is this? Well, you can say this is propene. I'll say not only that. Okay, yes, propene can be C3H6, but it's not only propene. So here's an example. Propene, let's put propene. Okay, this thing is going to be C3H6, right? So yes, here we're going to have it like this. We can have 2 carbons there. We can have a hydrogen here, and we can have our 3 hydrogens here like this. This is a type of a propene. This is going to be C3H6. We can even have, so this is going to be propene where you have your thing. You can also have a cycloalkane like this. Okay, like this. And these guys will have hydrogens like this. Hydrogen. Remember that carbon should just have 4 bonds. So here we have 4 bonds here. And if you see here, we're going to have bond and a bond here. And this is going to be cyclopropane. And both of them will have the formula C3H6. So these two are going to be structural isomers of each other. I mean, I can even give you something nicer, like we can have these guys, you know, we could have something like this. We could even have it here. It's fine. We have our OH. Maybe let me put it like this. OH. Then here we are going to have H and H. Then here we have our H and our H like this. Okay. So if we look at this, if I put, this is going to be C3 H8O like this, right? And if I put another way, I could have it like this, the same C3H8O, C3H8O. I could have it again like this. Let me remove this. I could have it like this, C, then OH, then C, like this. Okay, so these two give me this guy, C3H8O, but they are not the same. They are not the same. And these are structural isomers. Because if you look at their structural formula, it's not the same. Here OH is on the first carbon, here OH is on the second. So they are structural isomers. Here we said these two are structural isomers, C3H6. They are structural isomers. Why? Because we've seen that, yes, they all are C3H6. But when you look at their structures, their structural formulas, they're not the same. Remember, I said that displayed is a type of structural formula, and that is why we are calling it structural formula here. You can see it's not the same. So thus is structural isomers. These are compounds that have the same molecular formula but different structural formulas. And there are three types, which we're going to see in the next video, but we just talk about them. There are going to be three different types of structural isomerism. Okay, we know what a structural isomer is. Please don't confuse isomer with isotope. Okay, isotope is when you have things having the same proton number but different neutron numbers, which leads to different nucleon numbers. But here we are saying we have isomers, not isotopes. Isomers are compounds with the same molecular formula but different structural formula. So here, what are the three different types of structural isomerism, which are things that are going to have the same molecular formula but different structural formulas? What makes the structural formulas different? So there's going to be position isomerism. Basically, in position isomerism, what you are going to have is the position of your functional group. I would love to change this order. Okay, in the next video, I'm going to change the order because I want position and chain to be next to each other. So the very first one, let's call it number 1, is going to be functional group isomerism. Then we have number 2. So in functional group isomerism is the first one. We are going to have them being of different functional groups. Just like here, this is an alkene, okay? And here we have this is going to be a cyclic alkane, okay? So we call it a cycloalkane. So this is a cycloalkane, and same with an alkene. These two have the same molecular formula. Okay, one was a cycloalkane, the other one was an alkene, but they have the very same molecular formula. Okay, they have the very same molecular formula. So here we have them, but these are two different functional groups. So when you see the structural formula actually giving you two different functional groups, and yet they have the same molecular formula, that is functional group isomerism, which is a type of structural isomerism. Then another one is position. So for position and chain, there will be structural isomers. In other words, they will be having different structures but the same molecular formula. But they will be of the very same group. They will be of the very same functional group. Like if they're alkanes, they will be both alkanes but having different structures. When we say we have position isomerism, the position of your functional group is the one that changes. So the position is, if it's an alkene, either the double bond could be on the first carbon or on the second or on the third, whatever. The position of the double bond is the one that changes, but both of them will be alkenes. Okay, both of them will be alkenes, and both of them will be having the same length of the chain. The chain will be the same length, but the position changes. That is for position isomerism. And then for chain isomerism, the position is going to be the same. In other words, if the double bond is on the second carbon, it will be on the second carbon for both, but the length of the chain is what changes. If the double bond is on the second carbon, but the length is 3 carbons, or the other one, the length is 5 carbons, the length of the chain is what changes. Okay, we'll see that as we look at examples. We are going to have a look at all that. So in chain isomerism, the chain changes. In position isomerism, the position of the functional group changes. In functional group, the functional group changes. So whatever isomerism, if it's functional group isomerism, then it's the functional group that changes. If it's position isomerism, it's the position of the functional group that changes, but the chain will be the same. If it's chain isomerism, it's the chain that changes, but the position of the functional group is going to be the same. We're going to look at that in the next videos. Make sure you master it and you'll be fine. Goodbye for now. See you in the next video.